During a research experiment, it was found that the number of bacteria in a culture grew at a rate proportional to its size. At 5 a.m., there were 2,000 bacteria present in the culture. At noon, the number of bacteria grew to 3,100. How many bacteria will there be at midnight? So, we're assuming that we're following another exponential growth model. We're going to use A equals A naught e to the kt. So let's remember what each one of those stands for. You have A naught, which is the initial amount. You have K. This is either your growth or decay rate. And in this example, our bacteria culture starts at 2,000 and grew to 3,100. So this one is going to be a growth rate. And whenever it's a growth rate, K will come out to be positive. And then T stands for time. And A, this is going to be your amount after time. So we need to find the growth rate. And with the information that was given here, at 5 a.m., there were 2,000 bacteria. And then at noon, we have 3,100. So we have at 5 a.m., which we'll consider our initial time, we have 2,000 bacteria. And then at noon, okay, so we're going to count from 5 a.m., that would be 6, 7, 8, 9, 10, 11, 12. So that's 7 hours later. We have 3,100 bacteria. So with this information, we're going to be able to calculate the value of K, our growth rate. And once we get the growth rate, we'll have a complete model for this scenario, and we'll be able to answer this question that is posed at the end. So we're going to start by finding that growth rate. So using our exponential model, A equals A naught e to the kt, we have our ending amount being 3,100, amount after time. Our initial amount is 2,000. And our K is our unknown, and we have a time of 7 hours, which has passed. So this is our variable K, which we're trying to solve for, and it's in the exponent. So we're going to use our exponential methods to solve. We're going to isolate this exponential by dividing both sides by 2,000. We can cancel those zeros out, and that reduces down to 31 over 20 equals e to the 7k. We can solve this by either making the bases the same, taking the log of both sides, or converting to a log. Making the bases the same is not possible here, so we'll use one of our other methods, and I prefer to take the log of both sides. I'm doing natural log on the left, natural log on the right. Once you introduce the logs, you get all of the properties of logs that you're available to use. And one of them is the power rule, which allows you to move that power out of the exponent and into the coefficient. We have 7k natural log of e. On the left, we'll have natural log 31 over 20. Natural log of e is 1, so this simplifies to be 7k, because 7k times 1 is 7k. And then we can divide both sides by 7 to get our value of k. Let me write it out over here. We have k equals natural log of 31 over 20 all over 7. I'll type that into my calculator to get an approximation of the growth rate. Remember we said it should be a positive value. So you can follow along with the buttons that I push. Down here at the bottom it says key press history. We've got natural log of 31 over 20 over 7. And so our growth rate is 0.063 if we round to 3 decimal places. And as I've said before, we are not going to use that decimal approximation. We're going to use the exact value because rounding early on in this problem can cause rounding error once you get to your answer. So now we have our model for this situation, and our model for this situation is A equals A naught, our initial amount of 2,000, e to the k, we just found k, natural log of 31 over 20, divided by 6, t. So now that we have this model, we can substitute any value of time into this model to find out how many bacteria will be at that time period. So we're interested in how many bacteria will there be at midnight. So at midnight, that would be a 12 additional hours from noon. So that would be 19. 12 plus 7 would be 19. So we'll substitute in for a time of 19 hours. And as I've said previously, I like to write that 19 in the front because there are less parentheses that need to be typed into the calculator that way. So we'll type our expression into the calculator, 2,000 e to the 19 times natural log of 31 over 20 over 6. So after 19 hours, we will have 8,012 bacteria. We'll round to the nearest whole number. So at midnight, there will be 8,012 bacteria present. Thank you for checking out my videos. Have a great day.